Alrighty, come on in, come on in. We are going to kick off. Welcome to Cloud Native London. Stragglers, you can come in. There's lots of space still sort of around the sides. If this is your first time, then we are a strong, open, diverse developer community dedicated to the cloud native platform and technologies in London. I am your host. My name is Cheryl. I work for ARM as Senior Director, but most people know me from CNCF and my time there. Tonight, we have 3 talks. So our first talk is going to be from Mikołaj, and it's going to be overcoming legacy manufacturing challenges with Google Cloud. Then at 7:15, we'll have Webhooks and Webhook Gateway from Subomi. We'll take a 15-minute break at 7:45. So you can go out, you can get whatever drinks and pizza and use the toilets and come back. And then at 8 o'clock, we will have using and misusing Kubernetes dynamic admission control from Richard. Then 8:30, we're going to wrap up. And for those of you who want to continue, we'll go down to the pub, which is called the Conductor, straight out of the building on the left. And we will hang out for as long as people want to. There is a conference coming up called the DevOps Conference coming up next week, I believe, Thursday next week. And we have a promo code for you. So if you want to get 50% off, then you can use cloud-native-london, or you can scan the QR code. We'll give a moment. Okie dokie. Yep. Okay, so we're going to do a bit of live polling. Please grab your phone and you can go to this QR code or to this link, cheryl.com/p. Doesn't require you to download anything. It's just a web poll. And I'm going to ask you 2 questions about yourself, and then a couple of questions from our speakers tonight on how you use cloud native. So first question, is this your first time at Cloud Native London? I see people already starting to submit their answers. So we have the yeses and the nos. Yeses are catching up a little bit. Oh, yeses have overtaken. The yeses have overtaken the nos. There are also people watching this on YouTube and on Twitch. So we're going to give a couple of seconds to see if any of those want to vote as well. Oh, it's so close. It's so close. Looks like we have 50-50. Oh, we'll leave it at 50-50. Yeah. All right, what's your job title? Just pick whatever's closest to what you do. So architect, application developer, backend developer, engineering manager, SRE/DevOps engineer, security engineer, or anything else. And SRE and DevOps are definitely in the lead for this one. 40+%. Pretty even split across others, 28% for others. All right. Let's keep going. So, first question, how many of you know about webhooks? So not familiar at all, somewhat familiar, or very familiar. Okay, let's see what are the results that are coming in. Pretty evenly split. So this came from Subomi. So is this what you were expecting for the answers? Yeah, okay. So hopefully people who are not familiar at all will still get learn something from your talk. How do you use webhooks in production today? So you send, you receive, you do both, or you do neither. Most people saying they do neither, but of the people who are responding, most people saying, yeah, both send and receive, and then pretty evenly across the others. And I think we have one more question about webhooks. Oh, how many of you are familiar with the term webhooks gateway? Not familiar at all. This is good, right? This means you have a lot to talk about. Okay. Wow, yeah, 80% saying not familiar at all. All right. Okay. Next question. Have you or your organization used Kubernetes dynamic admission control? Yes, no, what's Kubernetes? Or what's Kubernetes dynamic admission control? Oh yes. Okay, good. People truly, it's not the wrong answer to say what's Kubernetes. Okay, if you're here and you said what's Kubernetes, then I'm very happy that you're here and you answered that. Okay, so a bunch of people saying what is Kubernetes dynamic admission control, a bunch of yeses, a bunch of no's. So Richard, is this right? Okay. All right. Okay, so thank you very much for taking part in the live polling and for submitting your answers. Hang on to this link because when we do Q&A afterwards, then you can type your questions. I'll have a slide for each of the talks and you can type your questions in as we go along. Oh, a selfie. Okay, I need a selfie for social media. So I'm going to go to this corner and everybody will have to smile and wave this way. Okay, nice. Thank you, everybody. If you want to speak, we are now booked up till December. So please plan ahead. You can go to this link, cloudnativelun.com, and you can request a speaking slot. You don't have to submit your talk now. You can request a slot and then 2 weeks in advance, tell us what you're going to talk about. But I really encourage people to come and speak, especially if it's your first time and you've never spoken before. Please come. We're a very friendly audience. Sponsorship, if your company wants to contribute towards pizzas and get to know our community, that would be wonderful. You can also promote your own events. Okay, that is it. I'm going to hand it over now to our first speaker. So big round of applause, please, for Mikołaj. Please hand in these badges with the blue fobs when you go out, because the building doesn't want to lose them when we go out. Thank you.
Hi, guys. Okay, 1 second. So yeah, am I sharing the screen? It should be. Okay, 1 second. Because I dropped Cheryl, I think you're still sharing the screen. No, sorry. Start video. Share the screen. You can start share while other participants.
Oh.
Sure. Okay. Yeah. Window. Okay. Do we see everything? It's fine. Okay. So good evening, everybody. Thank you for having me here. It's my third time in London, but it's my first time to be here on this event. So it's even more special for me to be here. So it's an honor. It's an honor. Thank you. Okay. So today I want to talk to you how we overcome legacy challenges with modern technologies. And I will talk about some old systems, their weaknesses, and Google Cloud, in fact. And this presentation is a case study of our project we did for our startup client and how we leveraged Google Cloud services to speed up the solution delivery to the production. So yeah, my name is Mikołaj. I live in Poland and I work at the company called VirtusLab. And yeah, we are a company based in Poland. We have few other chapters around the world. And yeah, we provide software engineering services. We help our customers with clouds, data engineering, data analytics, platform engineering, application development, tooling, that kind of stuff. And yeah, we support end-to-end delivery experience. So we start from discovery call, planning, and so on. So to the end of the delivery and beyond. My area of expertise is Google Cloud architectures, orchestration with Kubernetes, infrastructure as code, automation with CI/CD pipelines. Yeah, so this is the plan for the presentation. We start with problem explanation, and then I will tell you in details how we engineered the solution, what decision we've made, and I will conclude with some numbers and results. So let's dive in. So what you see on the slide is the list of the 50 largest manufacturers in the world. So there's significant gap between first and last place on this list. And it's more than $200 billion. And why is that? So one of the reasons could be that some of the manufacturers are relying on the factories of the old IT systems and hardware designed in the 70s, 80s. So a few challenges come with such systems. The first one is super hard to give new capabilities of such systems. Like imagine systems written in COBOL, right? The second one, these systems live in the mainframes spread all over the world. And it's hardly possible to monitor the production globally. The third one is lack of real-time access to the production insights. And yeah, last but not least, secure access to external facilities. So manufacturers are very protective of their data, right? So there are new IPs, designs being produced right now, and yeah, leaking this data might be very destructive to the company. So if the manufacturers from the lower part of this table want to move higher, they need to create the production flow which actually meets time constraints. So for example, they need to pre-compute their parts better. Yeah. So let me give you a quick example. So in Poland in 2019, you needed to wait a year and a half for a new car, for example. And the problem was related with lack of the electronic parts. And not sure how the situation in Great Britain looked like. So I'm very happy to know that. And Bartek Antoniak, who was here, I guess, in June 2023, right? Something like that. He's the friend of mine from the company, and he owns Kia Rio. And he bought it in 2015, and in 2019, his car had more value than back then in 2015 when he originally bought that car. So you see the problem with not meeting the demand. Yeah, and there is a technology to overcome such industrial challenges, and it's a digital twin. So digital twin is a technology that gives you the capability to mirror physical objects or processes inside IT system in the virtual, as a virtual replica. So let's say we have machineries in the factory, right? So if we model these machines in the system, we mirror their physical capabilities, the life cycle, the configuration. The digital twin can be used to test virtually these machines. We can monitor them better. We can predict maintenance needs, or for example, even try to optimize them in some ways, right? Without directly touching these machines. So if we talk about manufacturing, the digital twin, for example, can be used to predict production capabilities or to simulate any other processes inside factories. To give you a glimpse of the history. So in 2019, the customer startup, for the sake of this presentation, let's call it Modern Manufacturing, approached us with intent of the collaboration. In 2020, we started POC, and 2021, we started to work on the production-ready architecture based on top of this POC and its findings. And as you can imagine, the startup reality is very dynamic. So we needed to be agile and smart about our time consumption. Sorry, too early. So thanks to that, we went to the production and we developed a few components around the digital twin, like streaming service, batch ingestion. We improved the API by moving it from the REST to gRPC. And yeah, in 2022, the first customer got onboarded on the platform. And yeah, as times goes by, we maintain the platform and we are getting ready for the edge because we want to be closer to the data. Yeah, so this is the architecture of the POC. It's super simple. As you can see, there's one Google Cloud project, one networking, one Kubernetes cluster, and few environments which live inside this cluster. And the main consideration behind the POC was cost effectiveness. And this is how the digital twin looks today. So as you can see, it's much more extended. There are much more Google services used, much more applications delivered. And basically this presentation is about how we go step by step from the POC to the digital twin, from the one which is on the left to the one which is on the right. So yeah, let's get into that. So the first step in our journey was security. It was one of our key foundations. And what we aimed for was the sensible project separation and access control. Example of productive naming convention we could apply. Some easy to set up and secure access to our applications, and just-in-time access for our team members. In terms of the project separation, we designed it like the following. So each environment has its own project, networking, Kubernetes cluster, stuff like that. And we decided to separate the configuration part outside of the environments and to store it in the specific project we call operation project. So we store Docker images, we store DNS configuration, and so on. This gives us capabilities to make the above projects immutable later on. And yeah, this is the example of the naming convention we followed. So what I liked about it, it's you clearly see what resource hides behind the name. Yeah, identity-aware proxy is a product from Google, which is the foundation of their security model, and that makes us also running that. So basically in 20 minutes we can secure our applications. So do you remember this logging screen from various services when you click login with Google and you see the white screen and so on? So this is exactly it. And when you decide that Google as an identity provider is not enough, you can easily expand this possibility, and when you enable the identity platform, you can configure it the way you need. Yeah, in terms of just-in-time access, it is not natively supported by Google Cloud, but it can be easily enabled because Google engineers provide us the application with which we can deploy, and we can have the mentioned capability. The next step was to think how we can create and manage our environments. So this is a typical flow how the application environment could be provisioned, especially in the cloud. But we need to keep in mind that we operate in the startup reality. So the time allocation is very, very important, and architecture might change. Yeah, so there were two ways we could proceed. The first one, which is what I call static environment. It is less cost effective. It is semi-automated. It has very long time when it hardly changes. Yeah, and second one, fully automated, very well engineered, testable, dynamic environments, but time consuming to engineer them. So this is why we went for the static ones. So currently we utilize 6 environments, 3 of ours and 3 of the customer. So that's 6, right? So it's not much. And we started with 2, so it's even less. So we didn't need the dynamic environment if you don't see the reason already. So half automated environments provisioned were more time friendly for us, and we use that time wisely. In a second, I will show you how. And we gradually add the code for the environment's deployment, so we move towards dynamic ones anyway. So this is how we used the time I mentioned. So we've been so event service is a component which connects to the physical facility, and that way we have production events, like from the production line. So during the workshop with the customer, we got to know that he extended his facility network to the Google Cloud, and thanks to the interconnect. And basically, the rest was easy, maybe I can say that, because the Google already has the private service connect, which basically handles the backbone network connectivity to the service. And yeah, we based event service on the NATS, this really great queue, if you don't know it. And why we use NATS? Why not Kafka? Yeah, so NATS is much simpler and lighter. And yeah, why not Google PubSub? Because we wanted something which will, which you can run both on cloud and edge. Yeah, each environment's heart is a Kubernetes cluster, and we went with fully managed version, which is the autopilot. So it manages for us underneath node configuration, auto-scaling, auto-upgrades, network and security configuration. So our only job related with the Kubernetes right now is actually to deploy our application. Yeah, another step would be the infrastructure automation. So Pulumi was our tool of choice. And I'm an engineer with 2 years of experience with Terraform and Pulumi, respectively. And great features from the engineering point of view, which Terraform lacked and Pulumi had, was the real engineering experience, like real automation with high-level programming language, out-of-the-box secret management tooling, and end-to-end encryption out of the box of the sensitive values in transit and rest. So this is pretty powerful. So it's not like I don't like Terraform anymore and I won't work with that, but I definitely recommend to give Pulumi a try. So while working with the Pulumi, you need to remember about basically the same stuff you need to think about while working with Terraform. So there's a thing called infrastructure development lifecycle. I'm sure you know what I'm talking about. It is slightly different than software development lifecycle. And yeah, you don't want to see Kubernetes cluster being recreated when you run Pulumi app command or Terraform apply. The second thing, you need to keep your infrastructure in modules. It will give you better organization and it will minimize the blast radius when something goes wrong. Yeah, and last but not least, implement consistent naming convention. Yeah, it will enhance clarity and organization as well. So let's delve into the reliability part. What you can see here is our monitoring architecture. Google observability toolset helps us with error-based alerts, error notifications, logging, and integration to Slack. And yeah, we also utilize the Prometheus stack because yeah, our application lives inside the Kubernetes. We want to have the metrics. And yeah, based on that, we have a knowledge how the systems and the infrastructure operates, right? Sorry. Our tool of choice for the dashboard is Grafana. And there's one interesting requirement behind it. And we needed to make our dashboards accessible not only to our team members, but the potential future customers as well. And without giving them to access to our Google Cloud, Google environment, Google projects. The part on the right side is our pattern, how we integrate with the third-party monitoring tools. Let's say Dynatrace. So by applying the PubSub and customized virtual machine, we can easily separate the internal observability like logs, metrics, and so on from something we can share. Yeah, in addition to the monitoring of the overall state of the platform, we also monitor daily data imports. And what is that? Daily data imports is basically the main source for the digital twin. So this is the list of the assets being put on the production line in the future. So you remember when I talked about mirroring physical attributes and lifecycle and so on? So this is exactly it. So this is it. Yeah, and small explanation how we ingest this data. So customer puts their files ready to be ingested inside the cloud storage. We developed the API, which is running the data flow when invoked, and the data flow takes files and ingests the content one by one. And yeah, how do we know that data get imported correctly? So we have few alerts to to see the results. So we know that there are 10 files to be ingested. So if there is less, we throw an error. If the import fails or is partially successful, we also throw an error. And yeah, thanks to that, we know almost right away that something is wrong, and we can debug the files with the customer, and yeah, even before he alerts us. So this step is about how we are releasing software to our customers. So our process is semi-automatic. First, we define the dependencies of the components we want to deploy. We prepare release notes, and we invoke the pipelines, run smoke tests to see if everything works fine. So what you can see here is it is like literal mirror graph done before one of the deployments. We create this kind of graph, and we mark where we currently at, like this rectangle in the middle, and we share it with the customer. So this makes our communication much easier between the team and the customer, because you probably, if someone has a child, you know this like, are we there yet? Are we there yet? Where you are going on the road trip, right? So this is exactly this point. We had this situation with the customer. We decided to just share it, and this kind of messages were gone. So in terms of the release notes, we start from creating plain Google Doc, and we put the information like what are we releasing, when the release is happening, what will change, how we are gonna test it, and all of this kind of details. Yeah, we do that because the visibility and communication is important for us and our customer. So apart from that, our customer gets trust inside his customer size, because although this is a startup, he's being seen as more mature. Yeah, we have much more control over the deployed components, and the product itself looks more stable. This is an example of the pipelines we have for one of the applications, the dashboard UI. And yeah, what you can see here, we are applying naming convention here as well. We use the specific pattern like application name, purpose, and the destination, the destination environment. So it looks pretty clean, and we know specifically what will happen when we run the pipeline just by looking at its name. Yeah, and last but not least, let's briefly discuss the digital twin at the edge. So for the sake of the recollection, so this is how digital twin looks right now. And this is cloud environment. This digital twin lives in the cloud. And you remember the fourth challenge with old systems and manufacturing. So external access to production data. So if we deploy this digital twin in the data, we will be very close to it, right? And this step is in progress. This is the future, and this is how it could work. So cloud would be the global copy of the data. It will collect data from all of the factories which are connected to it, and these greenish boxes, these are the edges. So these are the facilities. In facility, we have digital twin deployed on the Anthos, and it hosts the data only related to the particular facility where it's deployed. Yeah, and more or less, this is how it could work. It's mostly being placed here as a conversation starter for later. So yeah. Yeah, to conclude the presentation, let's see the numbers. So we are connected already in two factories, and the third one is in the process. We handle 500,000 events daily related with production line. And yeah, our gRPC API is invoked 1 million times weekly. So it's going well. And we've ingested more than 180,000 assets. And this number is still going up. So something for the end, few takeaways. So remember to do your rough solution first instead of well engineering and wasting time on that at the very early stage. It's not worth to burn the time and money. Something goes wrong, so I'll just follow like that. Yeah, take your time when you're giving an issue to solve. Like rushing into the solutions will only cause problems and errors. Avoid being too attached to priorities. This is the startup reality in that case. And basically this week on Monday, we had the planning session. I had really cool priority I wanted to work on, and everything changed yesterday. So it was only one day. Yeah. Embrace the consistent naming convention. If you do that early, you can save much time on the organization, maintenance, and debugging the product. Yeah, and prioritize over communication. At the early stage, it can give you very many benefits. Yeah, because you will have the quicker information loop. Yeah, that's all from me. Thank you.
All right, we have a question already. Why did you choose CockroachDB?
At the time when we designed the production-ready architectures, we had few requirements, business requirements, and we wanted to have the same software at the cloud and edge, because back then, customer already knew that the edge is a thing. So we wanted to have the same software both on cloud and edge. And this on the diagram, this was the managed cockroach. Because yeah, we are a small team. We are around, there is around like 15 developers during the life cycle of the project so far. So yeah, this is why we chose the cockroach. Did Google support much from their startup business unit? Actually, yeah, they did. So we had very great experience with Google, with their support, like not the support related with tickets and something like that, but that still worked. But we in fact got the help from the engineers working on the Antos or on other areas like authentication. So we have great workshops with the guys from the APG. Yeah, so actually we are pretty happy about that. Could you give a bit more insight why you choose Pulumi over Terraform? Have you run any issues using Pulumi? At the very beginning, the customer wanted very high level of automation, like impossible with Terraform. Because Pulumi, why Pulumi is great is you can incorporate your infrastructure inside real programs. Like it's like infrastructure as a software, not only code but the software, which you have all the libraries support from or the community, right? Because for example, we use TypeScript as a language, and whole the npm you can integrate with Pulumi if you want. So yeah, this is why we chose Pulumi, and so far it's going well. We had some minor issues, but nothing which can be solved. And actually, Pulumi doesn't have like supports with tickets or something like that, but their community on the Slack is very well organized and super helpful. So I didn't have any problems like I couldn't solve. How much happened? Sorry. Why Grafana rather using Elasticsearch, which solves or overcome Dynatrace as well. So yeah, Pulumi's Prometheus stack is basically here on the market. It's for a long time. It has great community. It's a stack which solves the observability well. It's cloud native. This was mostly the reason. So Elasticsearch, like, we didn't like it. So it's not like there's no like reason like it was very slow or something like that. We just like the Prometheus stack. So that's all. Okay, so how much change happened in the customer side factory to generate the encrypted files? Yeah, so right now, not sure if this question is related to the Anthos and the Edge, because as I mentioned, this is the future. We do not have the digital twin on the Edge. It will be this year, but how it will change? Anthos gives us another layer where basically covers few stuff like inter-service communication and protocols and so on. So when being put inside the factory with internet connection, it's mostly seamless when deployed. Yeah.
Thank you very much. And a round of applause. All right, we are going to go straight into our second talk. So please come on up. I'm going to get rid of that sign here. Okay. All yours.
Hello. Hi. Good evening, everybody. I'm Subomi, and this is my first time giving a talk in London. I attended my first Cloud Native London sometime, I think mid last year, and I'm excited to be back and giving a talk. And I'm talking on Webhooks and Webhooks Gateway. And interesting, from the poll, we saw like 80% of the audience does not know what Webhook gateways mean. So I think I'll be spending more of my time there. And yeah, we can get started. So I'm Subomi, brief background. I started a company called Convoy. Convoy is an open source Webhook gateway. And on the internet, you can find me at Subomi Oluwalana pretty much everywhere. And the agenda is pretty straightforward. I would give some background introduction to Webhooks. Many people here already from the poll as well know what Webhooks are as a concept. And I would also go into Webhook gateways, juxtapose it with like API gateways, talk about like the architecture, the challenges, and Q&A. Okay, so let's jump right into it. So this is just for the sake of completeness, right? Like what are webhooks essentially? So if you look through the slide, you have like a complete picture. So webhooks are like the standard way we do event notifications on the internet, for example. In our companies or internally in the organization, like the previous talk, we use systems like NATS, Kafka, just any message broker of choice. But like when you come to like the internet and you're connecting SaaS business to SaaS business, webhooks are sort of like the de facto way we do event notifications. So I integrate Stripe and I want to know when my payments was successful. I integrate GitHub with PagerDuty and I want to know, or I integrate GitHub with Sentry and I want GitHub to notify Sentry about just any change. Webhooks are like the standard way we do all that event notification on the internet. And this is just like a diagram that really drives on the point. I love it so much. And I stole it from somewhere actually, from Paystack's documentation. And like it really drives on the point. The alternative way to achieve this is to call the API at an interval. And the way you get real-time activity from this is the frequency of your cron job. So if your cron job does 5 seconds, that's the minimum latency you get, or that's the baseline real-time you get. But webhooks allow you to get it as soon as it happens, which is pretty cool. I think it's pretty cool. And it's interesting to me because when Paystack launched in Nigeria 2016, and they launched their documentation, they were one of the very early companies from Nigeria that really, really took documentation very seriously. And it's not surprising that Stripe acquired them 5 years down the line for 200 million. It was really exciting in Nigeria. And they really took documentation and being developer first very, very seriously. And when I stumbled on their documentation, I was so stoked. I wrote a blog post about API and webhooks that was back in like 2017. And yeah, I'm starting a company on webhooks. And so the fast forward to this present age, the way the best companies do webhooks is to provide a log. And this is really important because one of the biggest challenges with delivering webhooks for SaaS businesses and for consumption is always the problem between, did you send me the webhook or did I not receive the webhook? Or was my system down when you sent the webhook? What went wrong between that integration? And what consumers do is they build, they try to invest in logging the webhooks they receive such that they can present it as proof to the provider that you did not send me the webhook, right? But the way, and then the way you go further to debug that is the consumers reach out to the providers and they have to create a support ticket. I didn't receive webhook Sunday morning. And because of that, one customer's payment is hanging, is not, some workflow is broken essentially. And so they provide a webhook log where consumers can go into their environment and sort of debug their webhooks without pinging engineers from the API provider. And this is common practice now. A few years ago, it wasn't common practice, but many, many API providers provide you a webhook log. And this is also this developer experience is also very important to why there's something called a webhooks gateway. Okay. So a webhook gateway is essentially just an abstraction for how you handle webhooks in your organization, right? And we sort of came up with the term webhooks gateway. So I'm not surprised that people are not familiar with it, but I won't say we came up with it essentially, because if you Google webhooks gateway on the internet, you would find references to it that are not related to Convoy, even before the formation of Convoy. But I think what we are trying to do is more formalize what it means to be a webhook gateway and generate ideas from all sources of people that are publishing webhooks today. And something that I found very interesting is if you take a, if you look at the spectrum of companies that send webhooks, there are several different pieces that they all focus on based on the industry that they exist in. For example, Stripe's webhook is very security focused. And that makes sense from a perspective of it's a payments company. They have features that are very payments focused. If you look at webhooks generated from companies like in the Web3 space, they have features that they care about, which is there's a firehose of events coming from the blockchain that they want to distribute to all the consumers. And these consumers do not necessarily care about all the events coming from the blockchain because it's a lot of events. And so they want fine-grained filtering on the payload structure, right? So a webhook gateway is essentially just an abstraction of how we do webhooks across the board. And I think this diagram helps us drive home the points very well, in the sense that an API gateway sits in front of your services, right? And API gateways is something we are very, very, very familiar with, right? You put an API gateway in front of your backend services, and then there's something missing here, which is the API gateway abstracts rate limiting, circuit breaking, retries, all the things that you do not want your backend services to have to think about. Because the whole essence of having a service-oriented architecture is that we can choose the languages or frameworks that best fits the problem we are trying to solve. So you can imagine that any of these backend services might be written in Python, in Go, in Ruby, and maybe in Python now they were writing AI applications. And so you can abstract all the things that you would rather write in each of these services and put them in one location and allow how everybody focus on their business logic. And the same thing essentially applies to the webhook gateway. The webhook gateway sits behind the services and is able to apply the circuit breaking, the signature verification, the retries, and the webhook log so that each of the backend services can really, really focus on their core activities. And sort of like have like this diagram that sort of goes into a bit more detail into the comparison of an API gateway and a webhook gateway. Essentially, the API gateway is an entry point, the webhook gateway is an exit point. API gateways are mostly synchronous. I mean, we have async APIs now, but the large part of it is synchronous. And webhook gateways are synchronous. Protocols that exist on the API gateway, like HTTP, WebSocket, gRPC. And the webhook gateway is mostly HTTP. Message formats and webhooks are mostly JSON. If you do webhooks with XML, please don't. And like API gateways are mostly stateless, so they can they have no states in them. Webhook gateways they have states, right? You want to webhooks are for the most part an at least once delivery mechanism, right? You want to ensure that it gets to the consumer at least once, right? And so because of that requirement of the system, you need states, right? If you try it once and the system is unable to process it, you need to try it again. And but API gateways don't have that requirement. Throughputs on both systems are high, but latency is also something that is different in the sense that depending on the application you're building, right? Latencies for your APIs are sub 100 milliseconds, and you can really go down depending on the systems that you're working in. But like webhook gateways, when you think about it, the real-time activity you see between switching from GitHub to Sentry is probably like 1 second. There is no real requirement for webhooks to have the latencies of Kafka, if that makes sense, right? For the most part, the webhooks that exist via the internet and deal with sub 1 millisecond, sub 1 second latencies. And that's why Kafka works very well for internal organizations and where we want real-time activity, because Kafka is literally just an append log. And most webhook systems are much more don't use much more, use a persistence layer that have higher latencies, if that makes sense. Okay. And yes, the high level architecture of a webhook gateway looks like something like this. The internal environments, the internal systems are publishing events into the gateway via a REST API. It could be a gRPC API as well. Or it could be via SQS, via PubSub, via just any message broker. You're ingesting these volumes of events into the webhook gateway, and the dispatch workers are able to push them out to the client endpoints. And this is like a high level architecture of what's going on internally in the abstraction of like a webhook gateway. And I'm focusing on the outbound parts, but like also many providers implement a webhook gateway with an inbound part where you have third parties ingesting events into your system, and you want a source of truth where you can then route the events to your backend systems and how you want to implement, how you want to manage these events essentially. So now I'll go into like the challenges of kind of, yeah, I'll go into a bit of the challenges of this system, just high level thoughts. And also I didn't mention that I wasn't meant to talk this time. I had a slot for June, but like a slot came out this month. I'm like, okay, I'll shoot for it. So I had to rearrange the deck because some of the things that I would love to talk about, we are still writing the code. But yes, so on a high level, yeah, challenges of a webhook gateway is first, again, to remind you of the first chore is you have different systems sending the events to one system as an abstraction because you want to provide a webhook log. And so the first thing you have is persistence. You need to store events in some way or form. And durability is important because we want to show a webhook log to our consumers. And the alternative to this is that each of your backend services needs to register these webhook events. And then you start to separate, the abstraction starts to not be a real abstraction, if that makes sense. So durability is the first requirement. The second requirement is we want fast writes. We want to write quickly. The system is write heavy, so we want fast writes on our persistence layer, and we want to also be able to index the payload so that we can retrieve it easily. Now, why this is important is webhooks are mostly JSON, and so what your consumers would be doing if you do not provide a webhook log, like I mentioned before, is they would implement it in their Loki, their Grafana stack, whatever stack they use for observability, to index the events that you send to them so that they can prove that nothing came true. But if all of this is provided on the webhook log directly, it provides an improved developer experience from the API provider. And the last point here is we want to archive and prune events. Sometime last year, GitHub published a post where they said, we no longer would show you events after 3 days on the, because GitHub has like a webhook delivery log as well. In your repository settings or your organization settings, you can see all the webhooks that have gone out to each of your endpoints. And they published a post last year saying, we give you a maximum of 3 days because GitHub's webhook is growing at a massive rate. They're starting to do billions of events, and then there's just no need for the events to be in the DB for that long, if not degrades the entire performance of the system. So we need a way to archive the events and also do it in an efficient way. If you use a persistence layer like a relational database, doing random deletes is also going to affect the write performance, right? So we also need an efficient way to prune all these events from the database. The second stage after you ingest the events is, and you persist it, is you want to dispatch, you want to deliver them. I don't know how many of us saw this event happened like 2 weeks ago. A show of hands. Nobody saw this on Twitter I think it was 2 weeks ago. So this event happened where a Vercel function, so we're all familiar with Vercel and the serverless environment. So a Vercel function, a customer had a Vercel function, or a user had a Vercel function that was experiencing a DDoS attack, and the user created, and the attacker created over 500,000 accounts in the space of 48 hours. And these accounts created subscriptions on Stripe, and Stripe sent Webhooks back to the serverless function. And then the Vercel sent him a $23,000 bill for consuming over, I think, 640 gigabytes of data. And then he came on Twitter and like, somebody help me. Yeah. So the challenge with Webhooks is you want to send the events to the consumer endpoint at a predefined rate. And if the consumer does not specify a rate, you want to default to something. And I think this is even more important as we continue to build edge functions and serverless functions, because you want to prevent a cascading failure, because this was a clean scenario of a failure that happened somewhere and it was cascading to the entire system. And so you need a way where all your agents dispatching events can rate limit the events, and not just rate limit the events, because the rate limiting will ensure that the consumer receives at a specified rate, but the circuit breaker will also ensure that if the system is having an issue, you can prevent your own system from having a cascading failure. And the second leg to the dispatch problem is two somewhat related problems. The first is the head of line blocking problem. So the head of line blocking problem is something we are very familiar with like our browsers, and trying to optimize for how we retrieve assets from the backend. But in the Webhook scenario, the head of line blocking problem is a scenario where you have a multi-tenant system, which most of us have from SaaS applications. And if you graph the activity of each tenant, most times there's always a whale. There's always someone doing the bulk of activity on the platform compared to the other tenants. And so if you use just one Kafka topic, for example, or just one queue, if you investigate, what you will find is it's possible that just one or two or three tenants that have the bulk of events, right? And if, for example, their endpoints, because the bulk of what you're doing in your Webhook gateway is managing endpoints, HTTP endpoints that can be hundreds, 200, 300, thousands, or tens of thousands of endpoints. And so if one of them is experiencing a failure, it can cascade to the entire queue, and other people would not receive Webhooks just because one tenant is having a problem. And again, if there are two problems that can occur. One is they are having too many events, and the other one is that they are having a failure. And because you want to guarantee at least once delivery, you also want to retry. So if the Webhook fails, you take it back into the queue. And so it starts to just clog the queue, and other events are not being processed. And so the easy solution to this is to just isolate the queues and enable each of your endpoints have their own separate queue. But it's also not that straightforward. The closest to something I've seen online to solve problems in a Webhook gateway is this system called Centrifuge, which was built at Segment. And there's a blog underneath that you can, I think it's a good read. That's the core of the Centrifuge system is to receive events and send it to all the integrations that Segment powers, which is the 450 integrations and just any other endpoint that they have. And they talked about how they went from using one queue and experiencing the end-of-line blocking problem, and they went into like using multiple queues and the problems they experienced with multiple queues, and they finally ended up with an architecture that uses virtual queues. And there are a lot of like interesting things to learn from this blog post that are relevant to webhooks or webhook gateway implementations. And this some stats from the architecture from the blog. I think it's a really good blog to read. Basically, how this works is they ingest tons of events on the director. They're able to push it into the jobs DB, which is MySQL in their system, and are able to prune it by not deleting, but dropping the entire table and dropping the entire table to S3. Yeah, so when events come into the director, what they do is they retain a cache in memory on the director, which is like a Go binary, and persist it. And they realize that 90% of the events that come in are able to go out by just retaining it in the director without having to pull the DB to read it and send it out again. And finally, the last part to this is the security aspect of your webhook gateway, which is pretty much the first 2 points are related in the sense that just enabling users register any webhook URL on the system is an attack vector in itself. And attackers can want to look into your environment and find just any URL that they can ping and do something nasty with. And DNS reminding attacks as well is common practices with DNS reminding attacks is in your webhook gateway, do not follow redirects. Send the webhook straight to the endpoint and communicate to the users that the endpoint would not follow redirects. Slow root attack is just specifying a read timeout, a write timeout, so that attackers cannot exhaust the system resources with poor endpoints. Again, so back to Convoy's architecture. Convoy uses a similar architecture as this. We use everything in this diagram. When I wrote this blog post, I literally just wrote this from an extract of how Convoy operates internally, with ingest workers and dispatch workers. And SQS is sort of just an archetype of message brokers. You can use just any message broker of your choice. Yes. And the details of it is written in Go. It uses Redis for caching, async jobs, and Postgres for persistence. We formerly used Convoy with MongoDB, but there were several challenges with using MongoDB such that, again, it's hard to, one of the challenges we experienced was it's hard to upgrade instances, right? So every time you have a schema change in MongoDB and self-hosted instances, upgrading everybody's instances to the new schema was a pain point for us. And we found this surprisingly that users were more comfortable deploying Convoy with Postgres versus deploying Convoy with MongoDB. And some of the things that we haven't done yet, like I said, I was not meant to talk now. Some of the things that are interesting to us, we use in Postgres is you can increase the performance of pruning the database with, e.g., like centrifuge architecture, dropping the table, or using partitions and partitioning by date time and just dropping after a certain time period. Yes, so you can scan this QR code to find Convoy. That is the repository. And thank you.
Thank you very much. I'm going to take over your screen share for any questions. We have maybe a minute for questions. Okay, let me give you this.
Thanks a lot. So
Hold up.
oh, really?
Microphone.
Yeah, looks lovely. So in terms of state of current market, everyone is really happy to know what about costs. So let's just imagine I'm your customer. I'm coming to you and I need some solution for yesterday and as cheap as possible. Which of your solution, I mean API gateway and Webhook gateway, are more cheaper, and what about costs of both solutions? Thank you.
So Webhook gateways are not a replacement of API gateways. Instead, they are complementary to API gateways. So API gateways solve a problem of the inbound into your environment. Webhook gateways solve the outbound for event notifications. And it's you can get a high throughput cluster on cheap machines. I mean, I know users deploying Convoy sending like tens of millions of webhook per day on really, really small machines on AWS. So it's really cost effective as long as you also watch the cost on the persistence layer where you configure the retention policy. So if you want 3 days, 7 days retention, you have to configure it. If not, this storage layer will just keep growing unending.
Yeah, thanks a lot.
All right, I'm going to wrap it up there. We're going to go to a break now. Another round of applause, please. For Subomi. Okay, please come back at 8 o'clock for our third talk. Thank you.
Thanks a lot. Where should I
Oh,
put
yeah.
it?
Oh, yeah, I'll put it back.
Thanks.
Thank you. Come in, please sit down. We're about to kick off our third talk of the evening with Richard. Please come on in and sit down. Oh, it's just the Wi-Fi being slow, I think.
Oh.
First step. First step down.
First step is done.
Yes, exactly.
Right, try to see whether any font is actually being.
I think it was fine. That's good. Okay, please come on in and we are going to kick off our third talk of the evening. So please, a round of applause to welcome Richard.
Thank you. Good evening, folks. I hope the food coma from the heat and the beer and the pizza has started to wear off even slightly by this point. So I have been hiding in the audiences of these meetups since about 2018, and I'm glad to actually bring you some bad ideas. If you wanted some good ideas, listen to the earlier talks. These ones mostly focus on the bad ideas I've seen and have done, and hopefully, you know, help you folks avoid some of those pitfalls. I'll wait for the photos to be taken. There we go. All right, so what am I going to show you? These. So how you can use these to secure clusters, how you can use these to take down clusters. Please don't. And also how some new functionality works that was added in Kubernetes. I have it later. So for the one person in the audience who is brave enough to admit that they don't know what Kubernetes is, it's this. Moving on. So in Kubernetes, there are lots of API requests. And generally, how these go is that you're a user or you're a bot or you're a machine. You make an API request to the server, the Kubernetes API server, and it then does authentication authorization. And after that, once it's confirmed that your request is valid for whatever that means, it then goes through admission control. So no one can read this. I'm going to walk through it one at a time, but it's just generally to give you folks the idea that the request comes in, it goes through many stages of admission control, and then it gets sent back. So I'm going to be talking about dynamic admission control. This is different from static admission control. Static admission control is what's built into Kubernetes. Like, this is a pod, this field is a string, this field is a integer. It's YAML, so it gets a bit weird, but conceptually that's static admission control. Dynamic admission control is bring your own logic. So we have already talked about webhooks. Behind the scenes, most of this is webhooks, and that didn't come up on screen. Oh well. Well, we know what webhooks are now, so we'll just move ahead. All right, we really are in interpretive dance mode right now. So anyway, it froze on the screen that has everything on it, so we'll take that. So first are mutating webhooks. These are called first. The key is in the name. Kubernetes will call out to your server for any matching resources and offer to let you mutate them. So you can use this for things like you have the same workload that runs on multiple clusters. Each cluster has its own registry. For some reason, you don't do templating and instead override the registry at runtime. So you would configure, in this case, a mutating webhook. It checks the container registry that's on the end or at the start of the image in every pod that you choose to run. And it will then edit that to point to the correct registry for that cluster. Another example would be adding some default annotations based on the namespace that you have. So you could do this for cost attribution. Some places do this. It's based on the annotations, and you could have a workload that just does that for your developers. Again, do it in your repo if you can. So these are called first, and the way that it works is that all of them get called. If any of them mutate, it gets resent out to all of them again, and this continues until they stop updating. And then the other thing, which is slightly odd, that Kubernetes lets you do is that the mutating webhooks can choose whether that object is allowed or not. So, for example, you look at this pod and it's looking at you funny and you just say, nah, you're not allowed in here. This applies for every API resource that you've got in Kubernetes. You just have to configure it correctly so that it consumes that. This also works for custom resources. So if you're running some operator that you've got yourselves, for example, ice cream machine, and that dispenses ice cream, and you're out of ice cream, then you can just have a webhook and it just says, nope, no more ice cream. I hope this works. Cool. So the next piece, which is new as of Kubernetes 128, is validating admission policies. Very quick show of hands. Who even knows that this is a thing? Okay, that's actually more than I expected. So these are exactly the same as everything that you can do with the mutating webhooks and validating webhooks. However, you don't need to bring your own web server. You don't need a webhook gateway. You don't need a webhook server. You can just bake it in. If any of you have the misfortune of dealing with like GCP's API conditions, authorization conditions, the same language for that, so it's Common Event Language, CEL, is the same thing that's used for these. Yeah, Google project, who knew? And all you can do with these is decide based on your logic, yes or no. Is this allowed in or is it not? Yeah, we're really not having luck here. I was going to show one. I will restart the screen share. No, I won't. It has entirely crashed. So this slide genuinely is all I get. I should have known better than to trust Firefox and Linux and Zoom. Like, oh, that's just a terrible choice. So you can use those. I can show examples afterwards. I'm not going to try and do an interpretive dance. But again, based on things that are in the object you're trying to decide upon, you get to make your choice. Ah, there we go. Now it has successfully crashed. Right. Refresh? Nope. All right. Well, whatever. We'll just move on. So, in terms of the policies, what they do. So it doesn't matter whether it's your own server or whether it's this common event language thing that's making the logic choice. You get to define what it's listening to. So which objects do you care about? So this could be deployments, this could be pods, this could be ice cream. And you get to choose whether it's allowed or it's not. If it's a mutating one, you get to say, I want you to make this change to it. The other thing that's worth bearing in mind is that you have a failure policy. So for your servers, say your server doesn't respond in time or it broke. What should Kubernetes do? You have two options. You have ignore. So it would just go, I didn't care what that had to say anyway, and just let it in. Or you can choose fail, which fails closed. So if your server goes down, none of those matching API requests can come through. None of them. You can really easily take down a cluster with that. Kubernetes does do a couple of things that help save you from yourself, which is none of these dynamic emission controllers can listen to their own objects. So no validating emission controller can edit or can choose to not allow a validating admission like update. You can't lock yourself out with these. You can really ruin your day, but you can't lock yourself out. You can also register on verbs. So say, for example, I'm only interested in things being created, not updated, or connect verb actually ends up being quite interesting for some of the stuff. So yeah, a more realistic scenario, which again, I cannot show you, for a validating admission policy would be you have a sensitive namespace. In that sensitive namespace, your thing is so secret and secure, you need to use a different container runtime. So instead of using that standard run C, you're instead running it with some kind of VM-based solution or gvisor. Like really, this is top secret stuff. You can just say anything in this namespace that tries to run without that, denied. Straight up denied. You don't get to run this with run C. You don't get to run it with Docker, secure or not. Like there is no middle ground. So, all right, covered that. Oh, I don't get to show the ugly JSON. What is this? So, what do you actually get from the Kubernetes control plane when a request, whenever Kubernetes decides, yep, this meets your requirements, I'm going to send it over to you. You will get an uglified line of JSON. Inside that, you have the Kubernetes object that the person or the machine has sent to you. You will also have extra metadata. So you will know what user sent you it and what groups they are in. As an example, if it's a machine, it would tell you what roles they have. So you can do some quite advanced logic if you wanted to on top of the default RBAC, ABAC, any kind of ACK that you've built on top of Kubernetes. You can get really fancy with it. So some downsides of doing this. Your code takes time. Your code could take a lot of time depending on what you're wanting to do. You're on the hot path for every single request coming in. So depending on what scheduling requirements you have, you could get yourself in a lot of bother with that. For the validating emission policies, that's running on the control plane. So if you write some really fancy policy, you're taking up CPU on your control plane. Hopefully not a lot. That's why they've gone with this rather unusual language. But conceptually, it's something to be wary of. Also, if you're mutating resources, make sure your mutations are idempotent and that really that they're idempotent. For example, if you keep updating a deployment, you just keep making more replica sets and more replica sets and more replica sets and more replica sets. And before you know it, you have entirely broken a cluster so badly that no one in tiers 1, 2, 3, and however long it took for them to actually get an SRE in, you can't recover that cluster until you get to an SRE who goes into the etcd, for your cluster and fixes it. I'm talking about a managed service here, which I will not talk about. It was self-inflicted, but you can really get yourself into a mess. So now I've talked about using, I'm going to talk about some proper uses, which again, don't show up. So genuine proper use case. You have a validating webhook. So this is the final thing that gets called. This means that you know the state of whatever's being created. You don't know whether it was genuinely allowed because they all get called in parallel. And if any of them reject it, that's a request rejected. But you do know, I know this is the state of this object that's being requested. So your validating webhook can make its own arbitrary API calls. So it goes off to a central service to see whether your application team has enough quota left to pay for some workload. Say, for example, you're running a grid, heavy batch processing, namespace limits may not be appropriate. So your service will need to go off and talk to something else to see, does this team have any quota left? Yes. Okay, cool. Here we go. In terms of a mutating webhook, you can set a default user ID if one isn't set in the manifest. So say, for example, you're wanting to prove to your developers that actually running as non-root is fine and works okay. And really, you don't need to worry about it. In a dev namespace, you could turn this on, force everything to run as non-root, and show them that it works. Again, there are usually better places to do this, but it's something you could do. And in terms of the validating admission policy, you could just make sure that everything confirms to your naming convention if you're feeling really petty. So you could make sure, yes, it's named absolutely correctly. Otherwise, no, you don't get to play on my cluster today. So now we've talked about good things to do. Let's talk about bad things to do. So in terms of misusing these various dynamic admission control pieces, what can you do? You can have a mutating webhook that injects a post-start hook that kills your main binary after some amount of time for some hopefully authorized chaos engineering. Please, please, please get authorization for doing that, but it'd be really funny. You could have a validating webhook that listens to any secrets being made on your cluster and send it off to your friends. Just please don't do that one. You could also register a validating webhook to listen to all resources, all verbs, and you could use this to create an audit log for all creations and mutations on that cluster, because a certain cloud vendor makes it really, really, really expensive to get audit logs. This is meant to be a plug for my open source Kube Audit REST project, which I'm happy to talk about at the pub, which was set up for exactly that reason. You also could use a validating webhook. Say, for example, your webhook detects a deployment to production at 6 p.m. on a Friday. It can make an API call for you to the coffee machine to get it brewing already. So, key takeaways, which don't show up. How you can use Kubernetes Dynamic Admission Control to secure clusters. How you can use this functionality to take down a cluster. Please don't. And how the new validating admission policies work. In terms of useful resources from this, which hopefully I'll get up during the question section, go to the Kubernetes docs. They're really good for this stuff. I've written a bunch of them, rewritten a bunch of them. They're generally very good for explaining how this works, when it works. And if you are having trouble with how much auditing is costing on certain cloud service providers, chat to me afterwards and I'll show you the Kube Audit REST project I've got. And with that, that is the talk. Thank you.
I think Richard deserves another round of applause for keeping going, even through the presentation woes. Okay, we've got about 10 minutes. So any questions for Richard, you can either type it in or you can have the orange cube of questions. Yeah. Can you catch this and then pass it back? Not confident throwing all the way. Thank you.
Given there was no questions, just from looking around the room, it'd be really intriguing to hear about the project that you are working on. I know you said at the pub, but since there's no questions, it's probably a great inlet to explain it a bit more if you're able to.
Yeah, if you stop sharing that, then I can put that up. Okay, moments of truth once again. And if it doesn't work, I will just send. Yeah, perfect. Ta-da! So there are links on the bottom. They're not QR codes because I have another talk on misusing QR codes. Anyway, so in terms of Kube Audit REST, I'm not going to name and shame a cloud vendor, but generally, most cloud vendors don't let you choose what audit logs you accept. And there is a certain message known as a subject self-access request, which will make up about 90% of your logs. And all this is well-behaved API clients asking, do I have permission to do this? Okay, cool, I'm going to do this, which is just pointless. If they just made the API call, you'd get, you know, I'm allowed or I'm not. And this was costing eye-watering sums of money, like just this one message. So what I wrote is a little tool that pretends to be a validating admission webhook, allows absolutely everything through it, doesn't care. And it logs it out to a file that then you can dump over into whatever security tooling that you're using, and then you can run your anomaly detection on top of that. Don't use it for production, but use it for, you know, non-production. Yeah. Yeah.
Okay.
Yeah. Are these costs associated with ingress and egress fees because it's webhooks and it's the data transfer between the internet? Just out of my own curiosity.
Sorry. So generally, managed service providers will charge you some very opaque fee structure to store your audit log. You don't get to choose what that is. It's on or off. And you get what they give you and you pay whatever they decide to charge you. That's not great. What Kube Audit REST does is it allows you to opt in to what resources you actually care about, what verbs you care about. Connect is a really important verb because that's whenever people are port forwarding or execing into stuff. So again, quite a high value one. And at that point, the only thing you have to pay for in most cloud vendors is, well, depending on where you run the workload, ingress or egress for those log messages. That's it. Yeah, but yep.
Yeah. Okay, so you yourself mentioned that this stuff runs in the control plane and has a cost associated to it. I have seen cases in the past whereby, for instance, you turn on the general log on a Postgres server that performance can degrade horribly. Why is this a good idea in that scenario? Because it sounds very similar. I mean, I can see the benefits, don't get me wrong, but it sounds like it comes with a potentially rather onerous cost.
Well, for one thing, it's managed service. So in theory, that's on the cloud vendor side to have to pay the increased cost. But more pragmatically, this is where you would have a failure policy of ignore and an aggressive timeout set. So if you're starting to slow things down, if you're starting to really overload things, then the API server can just run away off into the distance. Yes, you've lost that partial audit log, but you're doing this because you wanted a cheaper way to do it, not because you wanted a better way of doing it.
Yeah.
Yeah. Any further questions? Okay.
Thank you very much. Thank you. Okay, that's it for the evening. In fact, I can stop this. So we will be back again on the first Wednesday of every month back here. We were going to go to the conductor now. Please give back these blue fobs. There's a basket near the front. And have a very good evening. See you next time.